Hi, I'm Shimona Verma, Senior Product Marketing Manager with Emerson Actuation Technology. We are here at the global headquarters of Actuation Technology in Houston, Texas, where we showcase the entire Bettis electrics portfolio. Electric actuators have been around since the early 1900s. When the actuators were first introduced to the market, they were intrusive and conventional designs, and many of these conventional designs are still relevant today in the industry. The intrusive design provides the user with the capability to open up the actuator to change the required field configurations. Given that there is no display, user can still add mechanical indicator to provide valve position data. The conventional actuators hold value in the industry depending on the type of the application. However, as the technology advanced, explosion-proof requirements became more stringent, and as the field technicians started to work with electric actuators in three-phase power supply, it generated a need to be able to set up the actuators non-intrusively. In addition, since the actuators got much smarter, which means they now have sensors, microprocessors chip on board, the actuator is able to provide a broader range of diagnostic information directly on the screen or through the DCS system. This paved the way for smart, intelligent actuators, and users liked the idea that they could change the configuration setting using external controls and without having to actually open up the unit. Users could now have access to a lot more of the parameters and the torque settings that they previously basically could not, because they actually had to change a jumper setting or a wiring inside the box of the actuator. And the ease of setup and reliability helps reduce the initial installation cost and the overall maintenance cost as well through the life of the actuator. Take, for example, a remote oil field in West Texas. There are numerous well pads and each have 4 to 6 well completions per pad. And various pads might have a shutdown isolation valve. The valve is controlled or used to isolate the oil gas flow recovery line. When the well pressure gets out of specified pressure range, the well kill valve is then commanded to go into fail-safe close to isolate the flow line and shut in the valve. Well, this is for the protection of the well itself and also to ensure safety for above-the-ground infrastructure. The project required or called for a solution that would ensure reliable shutdown system and safety at the site. Keeping in mind that these were remote sites and there were multiple well pads that required a similar setup, the simplification and the specification called for data log that could be monitored and reviewed regularly, and a solution that could be cost-effectively maintained. These new specified capabilities led the user to select the Bettis RTS Premium Smart Actuator with fail-safe technology solution and SIL3 functionality. The RTS meets a lot of demanding applications that in the past electric may not have been considered. That includes mechanical fail-safe for ESD or SIS applications, or fine control on, say, a Fisher Globe or VPO type of valve. This intelligent actuator fits most of the on-off applications, but is best recommended for applications that require continuous modulation for process control and/or fail-safe. There are 2 variations of the RTS design: the compact and the fail-safe series. The compact portfolio that is most suitable for your process control applications can be configured for 3 different type of valve type outputs: multi-turn, linear, and quarter-turn. What we are going to look at today and talk about more in detail is the fail-safe series part of the portfolio. There are 2 basic designs for the fail-safe. One is the quarter-turn that meets the requirements for your fail-safe quarter-turn applications, and the other is the fail-safe linear. And what we have here today is the fail-safe quarter-turn model. This is a FQ03 with a max torque of 300 Newton meter. The fail-safe quarter-turn design basically consists of the smart, non-intrusive actuator that houses the key components like the display board, logic board, a fail-safe board, motor coupled with a variable frequency drive. The base actuator is connected to a rack and pinion assembly that is mated to a non-rotating ball screw mechanism and a spring module to produce the desired torque. Traditionally, with electric actuator in a fail-safe environment, companies have utilized batteries or supercapacitors to store the energy. But in this product, we are not storing the energy electrically. Instead, we are storing it mechanically via a spring return device, which also enables us to operate within SIL-3 level environments. For the well pad side, one of the other requirements was speed control. By opening the valve at a slower speed rate via the electric motor, the end user can prevent pressure surges or water hammering effect while bringing the well online. However, when closing the valve either via motor or mechanically via the spring, much faster stroke times are required to isolate the valve in emergency. In some scenarios, customers like to change the speed and travel to further protect the well from hammer effects and surge protection. That would require change of speed and travel. That is where the RTS variable speed technology comes to play. One very unique feature is the fact that it uses a pulse modulating DC motor with a variable frequency drive to control that speed. And this combination of components allows the customer to easily adjust the open and close speeds, independent of each other. This is achieved simply by a change in a parameter setting, which changes the frequency of the motor, not by changing any mechanical gearing or through pulsing of the motor. In addition to independent opening and closing stroke times, the customer can also set different speeds for local versus remote or even analog control. Speed changes can also be programmed through the stroke to potentially address any water hammer or similar process issues. Okay, now actually let's see this in action. What we have here is the fail-safe unit, as I mentioned before. And if you see on the screen, the valve is 100% open. Now keep in mind, because of time constraint, I've already set the parameters locally to change the speed mid-travel. What you will notice is when I begin to close the valve at about 65%, and listen to it very carefully, you will notice the change and you will hear the change in speed. So at about 65% it's going to slow down, and about 25% it's going to pick up the speed again. And the reason I did that to change the parameter was to show you that you can do the same in your field site. And it could be used to maybe change your settings simply because you want to prevent water hammer effects or any of the pressure surges that might be happening at your site. So let's watch this in action. All right, I'm going to close the valve and listen to it very carefully. Did you hear that now? It is slow. Did you hear that again? Did you hear the change in speed? And there we go. The motor and VFD also allows the RTS to be classified as S9 or Class D for continuous modulation duty, in addition to providing a position accuracy down to 0.1%, where in the past, this type of control could only be achieved with either a pneumatic solution with digital valve controller or an EH with servo motor. You now have the option for precise valve control using only electric power with the ability to provide fail-safe functionality. Also in well kill applications, the valve remains open for long periods of time. During this time period, when the valve is open, they tend to get paraffin buildup, and this causes reduced efficiency of the valve as the seats are clogged. So a partial stroke test or a PST is initiated on a regular basis can help wipe the paraffin off the seats and improve the efficiency of the valve. The partial stroke test function is field upgradable, which means that the same actuator can be used for various applications, especially since the operating speeds are adjustable. This results in significant reduction in actuator configurations and spare parts for the end users. And because the fail-safe function is achieved through a mechanical spring and not a battery backup or supercapacitor, the RTS can be used in a safety instrumented system up to SIL-3 without the need for redundancy when a partial stroke test function is initiated and utilized. There are other features that can be activated via smart code or software code. The same applies to changing operation from an on-off to modulating either external or PID, or enabling an analog output for a continuous torque or position transmitter. Let's talk a little bit more in detail about how the mechanical failsafe actually works. Under normal operation, the motor is powered in both clockwise and counterclockwise direction, and the linear assembly of the actuator is held in place by an electromagnetic brake. As long as the brake is powered through a fail-safe board internally supplied, the actuator will continue to operate either as an on-off device or modulate for process control. When the power is lost to the fail-safe board, typically through the loss of main power, the linear portion of the assembly will backdrive and quickly move it to the fail-safe position. When the power is restored, the RTS unit will auto-initialize and immediately be ready for operation again. Now let's see how the fail-safe actually works. So I'm going to actually turn off the unit. I'm going to take off the main power, and you will hear the sound, and you'll also see how the valve goes from open to close. Okay, now let's actually look at the fail-safe in action, right? We were looking at the fail-safe. What we're really looking at now is the valve. As you can see, it is 100% open. I'm going to plug this off of the main power supply. Listen carefully and watch carefully and see what happens. All right, there we go. So the valve is 100% closed, and the actuator went into fail-safe mode on loss of power. If you could hear that, if you remember that sound, that was the spring in action getting into fail-safe mode. Now I'm going to go back and re-engage and supply the main power. All RTS actuators come standard with a multifunctional local interface that is both simple to use and intuitive. This display includes 5 configurable LED lights that provide the user with visual data on the position and condition of the actuator. There is an open-close LED that can be configured to be either green or red. A yellow ready LED indicating operational readiness of the unit, and another yellow LED for torque indication or torque false. And finally, the last LED will indicate either a Bluetooth or an infrared interface when enabled. The red selector switch will be set either local or remote or for on-off control modes. And the black control switch allows the actuator to be opened and closed when the selector switch is set to local. Configuration settings can be modified in the on-off setting, and diagnostic information can be viewed while in remote. And finally, the local graphic interface can show you the position of the actuator as a percentage along the operating mode and the status of the unit. Now that you've seen the fail-safe functionality, I want to talk a little bit more about the manual override feature of the RTS. There are 2 manual override designs used on the RTS actuator. The fail last units come as a standard with the hand wheel override, which is a clutchless design that only engages while the actuator is being operated manually. On fail-safe actuators, a manual override is optional and features a clutching mechanism that can be locked in place. This override includes a torque barrier to prevent backdriving of the hand wheel, and a switch mechanism prevents the motor operation while the hand wheel is engaged. In addition, one of the cool features is the fact that the firmware can be easily upgraded on these RTS actuators through a USB connection on a micro SD card or directly through the interface. The mechanical fail-safe assembly, variable speed control, diagnostic capability, and field upgradable options, all packaged in this beautiful compact design, make the Bettis RTS your truly trusted, smart, intelligent electric actuator.